Assalamu alaikum. Welcome to School of Physics. I'm here for a few days, for a few lectures, which will be introductory in nature. So you have to cooperate with that. Maybe you might be knowing all these topics which are initially given, the lecture given here. So you have to cooperate with that. With the passage of time, we will shift on to the advanced topics. So for that, you have to cooperate for a while of time. So first of all, we will try to understand the basics about the physics. So that's why for today I have selected a lecture, a topic which is regarding the physics and the physical world. So today's our lecture will be, the topic is physics and physical world. So when you look upon the your surroundings, your environment, your wherever you are living, so you will see around different things, different phenomena going on. So these might include different phenomena like if you see some might be dangerous, even some might be slightly dangerous, some might be very much delicious in nature. Some things are there which are very much fascinating, like I can say the night sky. When you see night sky, like the stars, and further if you might be knowing something about the constellation, there are something like that. These are the group of cluster of stars, and some other phenomena which are daily observed, but you might not be thinking that there is a physics behind them. There is some sort of mechanism behind them, like the rainbow, which is very much fascinated by us, which is very much fascinating phenomena. Even we all enjoy when there is some sort of rainbow coming out on either side of our sky, which we look upon. So the mechanism behind this will be dealt by physics. Some other phenomena, like which might be, I can say I told you earlier that some phenomena may include the dangerous phenomena as well. Dangerous phenomena like earthquake. Okay, earthquakes, volcanoes. You might be all well aware about these weird things. Volcanoes, like storms. All of these, there is a phenomenon, there is a mechanism behind them. Why these are going on? Why such earthquakes occur? Why such volcanoes occur? What is the mechanism of the formation of the rainbow? Such a small, you can't imagine that a tiny droplet of water can form a huge rainbow. Can you believe that? And all of the mechanism behind that is dealt by physics. So we have to, with the passage of time, we have to understand all of these phenomena, why the things are going like that. So we will try to understand what physics actually is. A sort of, I will say, introduction. It will not be so much huge topic. It will give us an idea about the subject which we are going to conduct here, the lectures we are going to conduct here. So we will get an outline about the physics. To get the idea about what is going on inside the physics, but before that we have to understand science. We know science. All of us are well aware about this very fact that science, it includes the observations experimentations, and then implementations as well, and behind that we have to understand why we are doing physics. I earlier told you that we should do any study, we should do anything for a right purpose, and here science is studied for the purpose to serve humanity on the first place, and especially about the physics to understand. I already told you that to understand universe, to understand universe. So this must be our motto, this must be our goal, to serve humanity, and for the better understanding of our universe we study sciences, and physics is one category among different disciplines of the science, different natural sciences we can see. So for right now I will take the term science. It has been derived from a Latin word which means the science. It means to know, to have knowledge about. It simply means to know. That means that is the knowledge. So anything we are doing to get knowledge about that phenomenon, that specific topic, that specific branch, that will be included inside the science. But it has a domain. What domain? It must be including the observations, experimentations as well, because the things which are not under the experimentations, which cannot be observed, which are not observables, that doesn't come under the category of science. Like philosophy is good to know about. We also get the knowledge about different things, but that is not the science as such. That is not science as such, because it may be lacking the experimentations and implementation right now, because we can't conduct an experiment inside the lab to observe a phenomena which is discussed inside philosophy. For example, I can say the existence of feeling. For the existence of feeling, there are different philosophical views, but those are not observed. These are not observed inside the lab. But science deals even with the feelings. The science says that there is a mechanism behind the feelings. It is all the reactions, chemical reactions which are happening, which are going on inside our brain. So in that case, feelings are also dealt by science. Philosophy gives different theories, different suggestions, different hypotheses, but those are not what I said to you. Those are not being experimentally verified. These things cannot be experimentally verified. So it comes under the category of philosophy. Those concepts which cannot be verified, justifiable under the experimentation, which are not repeated under the experimentation under the same conditions if we apply. So we cannot again and again repeat these things in the lab, which cannot be observed into the lab. Those comes under the category of philosophy. But the things like the preparation of polymers, say for example, the preparation of polymers, we can do it inside the lab. We can observe the things, different things which are going on, and we can repeat the process as many times as we can. That comes under the category of science. So science deals with the observations, experimentations, and then afterward, to serve the humanity, we can implement it onto other disciplines as well. over to many disciplines. So, but with the passage of time, we are seeing that from the past experience, we have seen that there were different philosophies, there were different theories, there were different hypotheses given. With the passage of time, the earlier one was discarded. Then the new hypothesis, then a new theory came. It remained for some time, then after that it was also rejected. So with the passage of time, this is the beauty of science. This is the beauty of science. What? Beauty of science. Rejection of old, or we can say not experimentally verifiable, rejection of old, or we can say which are not the theories or the hypotheses which are not experimentally verifiable. These are replaced by new theories. This is the beauty of science. What does I mean by that? Say, for example, you might be knowing those who are interested to study the physics, those pupil are well aware about the few scientists like Newton, Kepler, Copernicus, Einstein. So I will take the example of these very personalities like Johannes Kepler. He was a great physicist. He studied, take the different data. He collected the data of Tycho Brahe. I don't know how to pronounce it. Tycho Brahe. He took and collected all the data which was experimentally observed by Tycho Brahe and deducted from that the elliptical paths of the planets, which were earlier suggested by Nicholas Copernicus. This is another physicist, great physicist, Copernicus. He suggested that there are circular paths. The planets follow the circular paths. This was replaced by Kepler on the basis of the data which was collected by Tycho Brahe. So earlier it was believed that the planets which are revolving around the sun, this is sun, and this is for example this is Earth. It is revolving around the sun in a circular path. Circular path. And other, for example, Jupiter as well, Saturn as well. All of these are revolving around the sun in a circular path. So his theory is also known as the heliocentric theory. What? The heliocentric theory. Helio refers to sun, which is here. Centric means at the center, which is at the center of here, around which the planets are revolving around it, like Earth, Mars, Jupiter as well. That's true. So he suggested a theory that sun is at the center and all other planets are revolving around it. This is called as the heliocentric theory. Earlier it was believed that Earth is the center of. Earlier it was believed that Earth is the center of universe, or say for example we will take for short the solar system. In this regard, in this example, solar system, this is called as geocentric theory. This is called as the geocentric theory. So earlier it was believed that the Earth is at the center and all other planets, stars, sun, including sun, which is the biggest part of our solar system, is also revolving around the Earth. But Nicholas Copernicus, he gave another theory. He suggested that no, as far as my data is concerned, as far as my research is concerned, the sun is at the center of the solar system and all other planets are revolving around it. But he suggested that these are revolving in the circular path. So Nicholas Copernicus theory replaced which theory? Geocentric theory. So geocentric theory was replaced by heliocentric theory, but it suggested that the paths are circular. And then after that, many years later, many centuries later, Johannes Kepler, he collected the data of this very person and suggested that these paths are not circular actually. These are elliptical, which is here. So at the center there is sun, and around these all other planets, say now Earth is here. This is Earth. It's revolving around the sun, but not in a circular path, in an elliptical. Ellipse. I'm not accurately drawing it, but ellipse is something where there can be two things at two different places, which are called as the focus, or focus 1, focus 2. And he suggested that the sun can be onto one of the forks of the elliptical path. So say it is here. So he suggested that the sun is at one of the foci of the ellipse, and Earth is revolving around it in a elliptical path, not the circular one. Similarly, Jupiter, say for example this is Jupiter, it is also revolving around the sun, but not in a circular path, but an elliptical path. Elliptical paths. So Kepler replaced which theory? Theory of Copernicus. Theory of Copernicus. Actually, we can say he modified it. Kepler modified the Copernican theory, suggesting that these are not the circular paths, but these are elliptical paths. So it is this beauty of science, and here especially physics, that with the passage of time, as we collected the data through different experimentation, through different observations, we can replace earlier theory which doesn't fit the data, and it can be replaced by some new which is well known, which is qualifying, which is I can say which fits the data which has been collected, and that theory replaces the older one. This is the beauty of the science. Now another example can be taken, which is regarding specifically regarding to physics. Say here, first, earlier you might be well known about it that earlier it was suggested that in Newtonian mechanics, which was suggested by Newtonian mechanics, that is Newton's theory of universe, Newton's theory of universe. This is what there is, and this is the final thing. They believe that this is the final theory, which is also known as the classical theory or classical mechanics. They believed that this was the ultimate theory, this was the grand theory which describes all the things inside the universe. But as the time passed, with the passage of time, different observations, different experimentations were done, and it was observed that this Newtonian mechanics is no longer valid. For example, when the discovery of atoms took place, molecules took place, even the smaller ones like electrons, protons, and other stuff like nucleus, etc. Classical mechanics suggested that few things about these very these particles, but the experimental data which was collected from this doesn't fit the data, or doesn't fit the theory which was given by Newtonian mechanics. So there was a need that this must be replaced by some other theory which must be describing all the experimental data, which must fit, which must suggest what is going on, what is the mechanism behind all these phenomena which are observed in these kind of particles, which are minute, tiny, small, or microscopic. So some theory must be there, some new theory which must describe the different phenomena which are taking place inside these particle systems. So this Newtonian mechanics, also needed some advancement. This also needed some replacement, modification. So this theory, Newtonian mechanics, was further then replaced or modified. We can say better is to be replaced, because Newtonian mechanics doesn't fit inside the world or inside the domain of these particles, this microscopic world. So it was replaced by some another mechanics which is known as the quantum mechanics. Quantum mechanics is that very subject, that very field which deals with the microscopic world, I will deal with this concept in a bit later. Microscopic world. So the thing I am here going to say is that there are theories given in this field of physics or in the field of science, but with the passage of time, as we collected different data from different eras, as the time passes, there is a need of modification in the older theory, and that must be replaced by some new theory. Like in case of here, we need to replace Newtonian mechanics by quantum mechanics. Further, quantum mechanics doesn't describe the things which are moving with faster speeds, the things, faster velocities, velocities. So this also needs to be replaced by some other theory that is known as the relativistic quantum mechanics. Relativistic quantum mechanics. So there was needed another theory which will describe the faster moving particles, like the speed of light or approaching to speed of light. So for example, any particle is moving with the speed nearly speed of light, say c. When we observe these particles under the theory of quantum mechanics only, the experimental data was totally mismatching. So this quantum mechanics need a modification. It need to be modified. By what? By relativistic quantum mechanics, which deals with the faster moving particles, faster moving coordinate system, whatever that is, faster moving speed, faster moving some particles. If we want to study those systems, we need to replace quantum mechanics by relativistic quantum mechanics. So this is all. After that, the bigger ones are dealt in this system or in this field. For example, we have to deal with the bigger system like galaxies, stars, galaxies, which are huge masses. So there we need some other theory, because relativistic quantum mechanics or quantum mechanics, this is only dealing with the microscopic world. So it will not fit into the bigger world, that is macroscopic world. So for that we need some another mechanics, some another theory which will be dealt with, which will be dealing with these huge masses. So for that we need another theory, like Einstein proposed theories. Other people like Hawking suggested few theories. So for that I can say like Einstein, he is well known, renowned. I will just for mentioning here the general relativity suggested by Einstein. So general theory came into being to deal with the microscopic world, the masses which are of huge bulk matter masses like stars, galaxies. So the thing I want to clarify here is that, which I earlier told you, that physics or in general science, there is a beauty in it, that every theory which needs to be modified, which needs to be replaced, is replaced by some new which fits the data, like I gave the example of this. So this is the beauty of physics, this is the beauty of science. Now we are going to discuss our subject in particular, which is physics. What exactly physics is. Here I will give some definitions and some introductory part of this very lecture. It will be a kind of introduction to this physics. So please cooperate. As the time passes, some new concepts will be dealt further. So for now we have to deal with the basics of our subject. So this physics, it is actually the basic discipline in the natural sciences. I told you that in general we talk about the science, but particularly our subject physics. It is the basic discipline in natural sciences. What does natural sciences mean? Natural sciences, that is natural sciences. What does that mean? It is the science, it is the knowledge, it is the experimentations and the observations which are dealing with the natural phenomena, the natural sciences, the natural phenomena, with the natural phenomena, or the processes occurring inside the universe. This term will come again and again, the universe. So I told you earlier that we have to study physics actually to understand universe, to understand the universe, to understand the universe. And this is the, if you have observed this is the title of our class. This is the title of our school, the School of Physics, Understand Universe. This is the main reason. School of Physics, Understand Universe. That is why, because physics deals with the universe. We have to understand different phenomena which are occurring inside the universe. We have to deal with all these stuff. Actually, physics, so that is discipline which deals with the natural sciences. It comes from a Greek word. Which means study or studying physical world. Or I can say tangible world for short, for simplicity, tangible world, which can be observed through our eyes, which can be observed experimentally. I told you earlier, which can be the things which can be reproduced experimentally inside the lab. That deals with the science, and here particularly with the physics, tangible world. And its domain is not only the physics which are dealing with the, I can say, the motion, the velocity, the acceleration of any body. No, the domain of physics, it also includes the biology, chemistry, all of these subjects. Like biology, this subject is called the biophysics. Biophysics, or chemical physics, or physical chemistry. All of these stuff are dealt inside the physics, inside the domain of the physics. So for that we have to understand physics. For example, here in just an example, in case of biophysics, say human being. You might have listened through your day-to-day life that human being is the most complex machine on the planet. So how does human being itself works? Look, I am moving my fingers right now. There is a mechanism behind it. There is a physics behind it. Why I am able to move this finger from this very position to that very position? There are chemical reactions going inside my body. So those chemical reactions, there is a mechanism behind those chemical reactions. And on the fundamental basis, the chemical reactions are caused by what? Electromagnetic force, which you'll come to know with the passage of time. Electromagnetic force. And electromagnetic force, electromagnetism, this is one of the fundamental forces of the universe, and this is one of the fundamental topics which are dealt by physics. So to understand human being, we have to understand physics, because we know that the human being itself is a complex machine, and to study any machine we need to study the physics of that very body. So that comes under the category of biophysics. So in short, the physics is studying the physical world, or I can say the tangible world. We can broadly For example, physics can be broadly, we can broadly divide our topic as like the basic laws of nature, physics of domain of physics. We can say that these include the basic laws of nature. That means what is the mechanism behind any working of anything inside the universe? How does anything work? What is the mechanism of the working? For example, I told you the example of the sun around which any planet is revolving. What is the mechanism behind the formation of the elliptical path? So that will be dealt with. There must be some basic law behind that, and that is the domain of physics, and this is the physical law. These are the physical laws which are to be dealt, physical laws. And there is then another part of it is the implementation, or we can say manifestation, how these are occurring inside the universe. Manifestation in natural phenomena. And this is the part which, for example, any physical laws, say for example the formation of the elliptical path, then the rotation of planet around the sun, formation of the seasons, and we are living here through these conditions, because these are physical conditions for us to live on our planet Earth. So this part forms the physical world, because if the laws are not implemented, if the laws are not manifested onto our universe, the universe not be existing on the first place. So first of all, physics deals with the physical laws, the basic fundamental laws, and then the manifestation and implementation of those laws over onto different phenomena of the nature. So these forms the physical laws, and the manifestation form the physical world, which we are observing right now. So further, I will deal with few topics, so cooperate for that. These will be short topics here, like you must be known about in physics. You must be you should know these two terms. One is unification, and another is reductionism. As the words indicate, this means to unify, to join, and this means to segregate or to divide. It's simple. To divide or derived from divided parts. What does that mean? I will explain to you. For example, take first the unification. For example, take the example of Newton. Newton, as you might have heard, that one day Newton was sitting under a tree. He was under a tree. So here is Newton. I'm not very much classic in drawing, so managed with that. So for that, Newton was under a tree, and you might have heard this. An apple was dropped over onto his head. He thought that why this apple fell down, and he came to know that, he concluded that there is a gravitational force. There is a force which is mass times the gravity, mass of this apple. And furthermore, doing research, having a deep knowledge about the different parts of universe, like he concluded that same law, same force applies to the planets as well. That is, this is sun, around it planets are revolving, planet is revolving. He concluded that the laws of nature which made this apple to fall down, same laws of nature are applied and manifested onto the sun and planet solar system to make the planet to revolve around the sun inside a elliptical path. So he tried to he tried to unify two different domains, like this is the terrestrial domain, we can say terrestrial domain. He unified terrestrial domain with what? Planets, stars, astro. These are the celestial domain. That is the domain of, that is, he unified domain of earth with domain of sky. This is the word unification. This is the term unification. You have to understand that. So for that, in physics, you try to unify different domains. For example, Newton did unify this terrestrial domain, which is applied onto Earth, with the celestial domain, which is applied onto sky. Similarly, in contrast to this, another term comes, reductionism. It is another sort of dealing with things. For example, we have a system, a huge bulk system, big bulk system of gases, with temperature something, with pressure something, with volume something. We have to study different physical things, which are physical phenomena which are going inside this system. Say this system is a star, like sun, or this is something which is even observed on this planet, our planet. Say it's ocean, huge ocean. As we know, we can't observe every part of our sun. We can't observe every part of our ocean. Say, for example, what we do for that, we take a small sample. Say from ocean, we take a small sample. But not only one, we have to conclude this very result over onto many samples. Because always error comes out. Error is there. So to reduce error, you have to take many samples. So for example, we take a small sample of seawater or the sun, which are we dealing with. We take a small portion for that to observe under a telescope. Say here, we take a small part of the system, another small part, and we observe it under the lab. This small portion is taken under the lab, under experimentation, and different phenomena which are going inside these small systems are observed. And after that, observing different samples, observing different small, minute, tiny samples from this very huge system which we have to deal actually with, but we cannot directly deal with that. So we take few small samples from them and conclude that this very, say for example, XYZ phenomena, or these are mechanisms by which we can understand this very sample. What does reductionism mean? It means that the same process which are going inside these small minute systems which are taken from the bigger one, same XYZ phenomena must be taking place inside the parent source, for example star, for example ocean. Any observables which are taking place inside the tiny samples which are taken from the parent source, these mechanisms must be followed in a similar fashion inside the huge bulk parent source. So if we join these small samples, this plus this plus this, same result will be followed in the original one, because these are taken from, we have reduced the parent source to smaller sources, to smaller samples. When we join these samples together, we will get back, when we join these different samples, we'll get back the parent source. So the phenomena which are occurring inside these samples must be occurring inside the parent source. And the mechanism which are governing and the laws of physics which are governing these samples must be also applied to this parent source. So that means reductionism means that we reduce a huge system into smaller ones and conclude that whatever is going on in these systems, these small samples, must be followed in the parent one. This phenomena, this type of theory is called as the reductionism. So we reduce the huge system into smaller systems and conclude a result from these smaller samples, smaller systems, and conclude from them that these must be followed, also followed in the source. Have got this idea? How to reduce? We reduce the parent into the smaller samples, then observe it inside the lab, taking some conclusion that these laws are followed inside this, these phenomena are taking place. In a similar fashion, these laws and these different processes must be taking place inside the parent source. So this is the theory of reductionism. So there are two concepts in physics which must be dealt always inside the physics, in the field of physics. One is unification, to unify different theories, to unify different domains, even though on the first instance that these must be seen that these are totally irrelevant, but with the passage of time you will get that two different domains can be unified. For example, and similarly, first I will deal with reduction. Similarly, reductionism means for huge quantity, for huge bulk system, we reduce it to smaller ones, try to understand these systems, and then apply it back to the parent source. So these are two main processes. These are main two theories which you must be knowing. Like in the unification, we unify, say for example, electromagnetic force with weak force. It is the most latest research. To give electro-weak force. I just gave an example of the latest. Maybe somebody among you must be knowing it. Electro-weak force or electro-weak force. This is for just an example. Electromagnetic force is something different. Weak force is something different, dealing with the nucleus. But the motive of unification is to unify two different domains. Similarly, reductionism is to try to understand a bulk matter, a bulk huge system, by reducing or taking the sample systems from that. So concluding from this, we can understand the actual source system. So this was all about the physics and different approaches we can deal with that. I think this class has gone a bit longer. We will deal with other terms with the passage of time in the next lecture. So please kindly subscribe, share, like this video, and cooperate with this. Try to understand. Our motto should be to understand our universe. So support the School of Physics, understand universe. I will see you in the next.